What are embeddings, and how are they used in RAG? Embeddings are simply numbers that capture the meaning of text. Think of them as a map, where every word or sentence becomes a point, and nearby points share similar meaning. This is why we convert text into vectors. It gives the model a mathematical way to compare ideas. In RAG systems, these vectors become the key to fast, accurate retrieval. When a user asks a question, RAG turns that question into an embedding, then finds the closest points in the vector database. It's a bit like flipping through a library card catalog, except the cards are organized by meaning instead of keywords. Interviewers love this definition because it shows you understand both the intuition and the role embeddings play in grounding an LLM's answers in real data. If someone asks why this matters, the smooth follow-up is simple. Without embeddings, retrieval would be slow and far less accurate. Understanding embeddings. Here's the key idea. When you feed a sentence like machine learning is fascinating into an embedding model, it produces a long list of numbers. Those numbers form a vector that captures the sentence's meaning. Words or sentences that express similar ideas end up with similar numerical patterns, and in the vector space, they appear close together. This is what makes semantic search possible. Don't worry if this feels abstract. Think of the vector space as a landscape where machine learning, AI, and neural networks live in the same neighborhood. Interviewers often ask why this works so well, and the best answer is that embeddings compress meaning into a form models can compare instantly. That's what enables RAG systems, recommendation engines, and search tools to feel surprisingly intuitive. How RAG works. RAG works in two clean phases. First is retrieval. Your question is turned into an embedding, and that vector is used to search a vector database for the most relevant text chunks. This step is what keeps answers grounded in real information. Then comes generation. The retrieved passages are fed into the LLM, giving it context to produce an answer that's accurate and supported by evidence. A simple real-world example is customer support. The model retrieves policy snippets, then generates a friendly, correct response based on company rules. Interviewers may ask why RAG matters, and the smooth reply is that it reduces hallucinations and makes LLMs usable in high-stakes environments. Once you understand this flow, the whole system becomes much easier to reason about. Common follow-up questions. A question that comes up often is which embedding models people use. A strong answer is that models like OpenAI's text embedding, SentenceBERT, and Cohere embeddings are popular because they balance accuracy and speed. Another common question is how to measure similarity, and the simple reply is we use cosine similarity or dot product to find vectors that point in a similar direction. You may also be asked about vector databases. Tools like Pinecone, Weaviate, and Chroma store embeddings so we can search them efficiently. And when someone asks why we don't just store raw text, the best explanation is that embeddings make semantic search fast, while keyword search misses meaning. Finally, chunking comes up often. We break documents into smaller pieces before embedding, so the search stays precise and lightweight. These answers show both technical understanding and practical awareness, which interviewers love. Great job learning today. If this helped you feel clearer or more confident for your AI or ML interviews, tap like so more learners can find you. If you want simple guidance for every interview topic, subscribe so you never miss the next lesson. You can share your questions in the comments. I read them, and they help me choose what to teach next. And if you know someone preparing for interviews, feel free to share this with them. Keep going. You're improving with every step. I'm here to help you grow.